Today's lesson is a topic that many of you are inquiring about. You know that the blood types, there are different blood types. We learned yesterday there are 4 types of blood: A, B, AB, and O. You should now be able to do a Punnett square, which is going to allow you to predict from one generation to another, given the fact if you have a parent that is heterozygous A crossed with a heterozygous B, what phenotypes you would get in terms of offspring. So today we're not really going to look at the Punnett square genotypes. We're going to talk about the interaction. We know that there are rules to blood typing, and we know that one just can't give blood to another because there are consequences to if you don't have a good matching blood type. But the reason behind it, some can give, but some can't. You may have some information, but it comes down to 2 words that you need to know: antigen and antibody. Whether it's pluralized antigens and antibodies, these are both proteins. So they fit under that category that we learned about well into the first part of the year. Antigens and antibodies are proteins. Antigens are proteins that are directly attached to the cells. And given that we're doing blood typing, antigens are not just found on blood cells, they're found on many types of cells. We're going to focus on the ones specifically found on your red blood cells. So they're attached directly to the red blood cells, and what they do is they identify your cells as being you, whoever you is. I have antigens on my body cells that would identify myself, and if someone's cells got into my body, it would recognize it. And the whole response behind here is the immune system. So your immune system recognizes antigens that are foreign, and when they recognize those foreign antigens, they attack using antibodies. So they are going to attack foreign antigens. And usually when you attack foreign antigens, they kind of, in blood, what will happen if an antigen is attacked by an antibody, all the blood that has been attacked kind of coagulates, it kind of blocks together, and that's what is harmful to someone if you're given a foreign blood that your body doesn't recognize. The antibodies fight it, they go to it, they make it clump together, and obviously within a vein or something, you don't want to have clumped blood. It will stop the circulation, and that's what can kind of be deadly. So you have to know your blood transfusions, especially if you want to be a doctor, you want to be a nurse, anything like that. You better know who can give to whom. So these 2 things, antigens, antibodies, I'm going to draw them in a simplified fashion. So what I'll do is I'm going to draw 4 different types of cells. Each one is going to represent the different blood groups. So you can draw these on a separate sheet of paper to kind of follow along. Upper left, I'm going to draw A blood. Here I'll draw B blood. Down here, AB, and here O. The letter that you are assigned for blood type is directly associated with the antigen that is attached to your red blood cell. So to simplify the diagram, I can't actually draw an antigen. It's a protein, a chain of amino acids. We simplify the method. An antigen that might be classified as an A antigen, I'm going to draw as a triangle. So these triangles that are directly attached to the red blood cell would be known as A antigens. It looks like a little sun in the end. So that's an A antigen. Alright, simple enough. The B antigen is completely different. It's got a different sequence of amino acids, so it's going to look different on the surface. Once again, these are just simulated antigens. They don't really look like this. Looks like a little flower. So that's the B antigen. Someone that has AB blood has a codominant genotype. It means that they have both antigens present. So therefore, what you're going to see on an AB blood type is alternating on this diagram. I've got some A antigens, I've got some B antigens. So they kind of go around as such to have both antigens. That's what makes it the codominant. If it was incomplete dominant, then it would be a different situation. It's like blend the 2 together, so it would be half triangle, half moon, but that's incomplete. This is codominant, so they both show through independently. O blood is actually, there's no antigen for O blood. O really means it's the lack of the A and B antigen, so it's completely bare on the outside, so I'm not going to do anything to it. Not only does your blood have antigens on the outside, it has those antibodies kind of floating outside. Your blood is not just composed of red blood cells. There is a liquid component to it. The rule of thumb is if you have the antigen, you don't have the antibody. You don't want somebody that has A blood to have the A antibody, because as soon as they connect with one another, that's what coagulates or clumps your blood. So if you have A antigens, you want to have the B antibodies. So you have A and B of everything. But if you have A antigen, you have the B antibody. So I'm going to draw the B antibodies like this. They're outside the red blood cell. They may be a little hard to see in the distance, but they've got a little antenna, and then the shape at the bottom of the antenna, look at that shape. It fits, it looks like the shape of the B antigen, because these 5 things that I just drew, these are the B antibodies. So guess what they do if B blood comes into this square? These antibodies will attack it. They attach specifically. It's a very specific attachment. So this antibody will attach to the antigens of the B blood and will attack it and clump together. That is not a good match. So it's really not good for antibodies to attack, because that means that a foreign blood cell is in your body, and that's not a good thing. So A people, if you have A blood, you have the A antigens with the B antibodies. So now let's assume, if we're now in this square, you've got the B blood cell, so you've got the B antigens. So guess what type of antibodies you're going to have? Hopefully you said A. And look at the shape of this. They're going to have that antenna once again, but it's going to look like the shape. It's going to fit directly over an A antigen. So you can label one of these A antibodies. So notice what they'll do. If A came over to this square, these antibodies are going to attack the antigens that are on the A blood cell. And when that happens, the blood clots. Not a good match. Down here with AB, they have both the A and B antigens. So therefore, the A and B combination has already been set forth. So therefore, there's no antibodies. Every square has to have something with A and B. This one, A antigen with the B antibody. This one, B antigen with the A antibody. This one has both the A and B covered, so therefore there's no more reason to have antibodies out here. If it had an antibody, it would just attack itself. You don't want that to happen. So there's no antibodies. Here, because there is no antigens, their A and B combination have to be put into the antibodies. So therefore, outside of someone that has O blood, you are going to have both combinations drawn the same way. You will have both of them out here. All right? So that's the breakdown of what you have in your blood cells in terms of antigens and antibodies. So now talking about the science of who can give to who. The rule of thumb is the more antibodies you have, the less blood you can get. Because the more antibodies you have, the more fighters you have. So therefore, the blood that comes in, it's going to recognize it and attack. The less antibodies you have, it means the more blood you can receive. Because you don't have these fighters. So if you don't have fighters, things can get in. Think of it like a country. The more army guys you have, or ladies, what you get is things are going to fight. So therefore, it's not good. But if you don't have an army, it's really not going to fight. So let's look at this. We know that B can't go to A, and I kind of explained that. If B came over to this square, what would happen is these antibodies would attack the B antigen. Imagine if B came down to O. What's going to happen are these fighters, or the antibodies, will attack again. They're going to attack that blood cell coming into this square, so that's not good. But if you reverse it, if I take this blood cell and I bring it into the B square, these antibodies have nothing to attach to because they don't have the antigen to attack. So therefore, this is a fine transfusion. You can go from this square, you can take this O blood and bring it up here. That's fine, but you can't go the opposite direction. Because if you bring the B down to this square, the antibodies fight. You take the O up here, there's nothing for these to attach to, so it's going to be a good transfusion. If I went from A to O, same thing. If I bring A down to this square, these A antibodies will attack whatever you just brought in. So it's going to be a bad match. But if you take O and bring it over to here, these antibodies that are in the A blood person, they don't attach to anything. No attachment is a good thing. No attachment means nothing coagulates, nothing is going to connect. With the AB blood, If you bring it over to this person, once again, the antibodies will attack everything here. It's got both types of fighters, so they will really attack the outside of this. So this movement is not good. Reverse it, bring the O over here. Notice, they have no antibodies, so they can't fight. There is nothing they can fight because they don't have anything to fight with. So this is a fine transfusion. So notice, nothing can go into the O blood square. But the O can go everywhere, which is why O is given the term universal donor. It can go to anybody. AB is on the flip side. AB can't go to anywhere because every time it goes somewhere, there is a fighter in the square ready to attack the antigen. In every square, there is something that will find itself attacking the AB. So therefore, it's not good to go anywhere. But if you reverse it, anything can go into this square because this square has nothing to fight with. This AB blood is known as the universal recipient because it doesn't have any rejection. All the cells can come in with no problem. Alright? Hopefully you get that. It is all about interacting between antibodies and antigens. The rule of thumb, if an antibody connects with an antigen, it is going to connect and fight. And therefore, that's bad in blood transfusion. If nothing connects, it's going to be fine. All right? In class tomorrow, I'm going to elaborate on, I know some of you are talking positive and negative. I'll explain that in class. It gets a little bit more tricky, but this is the basis for blood typing. So if you have any more questions about it, feel free to ask, but you'll learn tomorrow positive and negative. All right? I'll see you then.